Hello everyone, welcome back to Let's Talk. My name is Shivanshu Shukla. Here I am with the 9th part of the running video series. This video series is not only helpful for those who are going to appear in BHU entrance exam but also for every geology student. In this part, I will solve first 30 questions of BHU PET 2019 question paper. If you have not subscribed channel yet, please do subscribe. So let's start. First question says, two major processes of glacial erosion are. So, there are basically two processes in which glacial erodes, and these are glacial plucking. It is the lifting and removal of fragments of bedrock by a glacier, and it is the most effective ways in which glacier erode the land. And the second one is abrasion. In this erosional process, the glacial erode its bed and side walls with the help of tools of erosion, that is coarse debris. So, in glacial erosion, the two main processes which are associated are glacial plucking and abrasion. Now, let us check the options. First one is abrasion and glacial plucking. Abrasion and plucking. So, this is the correct answer. Second one is abrasion and attrition. Abrasion is associated with glacial erosion, but attrition, which is mechanical wear and tear of erosional tools in themselves, it is the erosional process which is mainly associated with wind and running water, and this is clearly not associated with glacier. So this is not the correct answer. Plucking and solution. What is solution? Solution is erosional process of running water, of sea waves, and also of karst erosion, and it involves dissolution of soluble material through the process of disintegration and decomposition of carbonate rock, and clearly solution is not associated with glacial erosion, so it is also not glacial erosion process. Next is plucking and attrition. Plucking is glacial erosion process as we have discussed, but attrition is again not a glacial erosion process. This is also not a correct answer. So, the correct combination of glacial erosional process is abrasion and plucking, and this is the correct answer. Now, let us proceed to the next question. Question says, which of the following is not a characteristic of barkans? So, first of all, let us know what are the characteristics of barkans. So, barkans are small, isolated, crescent-shaped sand dunes, and these are mobile. That is, these moves in the direction of wind. And these are a special type of transverse dune, that is, these found perpendicular to the direction of prevailing winds. Now, coming to the options, first one is it is made up of sand. Yes, this is the characteristic of barkans because barkans are sand dunes. It is crescent shaped. This is also involved in definition of barkans, that is, these are crescent shaped. So this is also characteristic of barkans. Now, next is it lies at right angle to the prevailing wind. This is also the characteristic of barkans as it is type of transverse dune, so it lies at right angle to the prevailing wind. Now, it never moves in the direction of wind. This is incorrect because this is not a characteristic of barkans because barkans are mobile sand dunes, that is, they move in the direction of wind. So, this is not the characteristic of barkans, and this is the correct answer of the question. Coming to next question. Next question says, river erosion and deposition jointly produce features such as. So, we have to tell that among these pairs, which one of the pair is produced combinedly by erosion and deposition. That is, for example, say nick points. So, we have to tell that nick points and terraces, both of these, that nick points is independently formed by erosion and deposition, and terraces is also formed independently by erosion and deposition. For example, say. Okay, so we have to tell like this. So, first one is pair of nick points and terraces. So, nick points, what is nick points? Nick points is a point of abrupt change in longitudinal profile of a stream. Okay, and it is associated with the rejuvenation of a stream. Nick points may be possible that it is associated with erosion, but it is not possible, it is not associated with deposition. So, nick point is not jointly formed by erosion and deposition. While terraces which are also known as river terraces, and the mechanism of formation of river terraces consists of two steps. First step involve formation of floodplains during the late mature stage, that is deposition. And the second step involve erosion of this floodplain because of rejuvenation, which increases erosive capacity of rivers. So clearly in the formation of terraces, both erosion and deposition act together. That is, terraces are formed jointly by river erosion and deposition. So we have got our one landform which is formed by jointly erosion and deposition. This is incorrect option because nick points are not formed by both erosion and deposition. While coming to next option, meanders and terraces. Meanders are what? Now look at here. Meander means bend of longitudinal course of the river, and in which in meanders there you will get a convex side and a concave side. In convex side you will get a deposition of sand gravels and alluvium like here, and in concave side the concave side is subjected to severe erosion. So meanders are formed by both river erosion and depositional process. In first option we have got our terraces, that terraces are formed by jointly formed by river erosion and deposition. Now in second option we have got meander, that these are jointly formed by river erosion and deposition. Now other next is terraces. So meanders and terraces, so these both are formed by jointly river erosion and deposition. So this is the correct pair. Next option, meanders and floodplains. Though meanders are formed by both river erosion and deposition, but floodplains these are only formed by deposition. So this is not the correct pair, which is produced jointly by river erosion and deposition. Again, next option is floodplains and terraces. Though terraces are formed by both erosion and deposition, but floodplain is again formed only by deposition. So this is also not the correct pair. The correct answer of this question is meanders and terraces. Next question says, the terminal moraines indicate that the glacier. So first of all, you should know what is terminal moraine. Terminal moraine are those that formed at the end of glacier. These are also known as end moraine, where the front of glacier remain stationary for a long time. Now let us check the options. First option says passed over soil covering. This is not terminal moraine. Passed over coarse sediments. This is also not terminal moraine. Was stationary for a long time. Though by definition itself, terminal moraines indicate that the glacier was stationary for a long time. So this is the correct answer. Was active for a long time. Please comment down below in which type of moraines that indicate that the glacier was active for a long time. Okay, these two, passed over soil covering and passed over coarse sediments, represents the transportation by glacier. Okay, now coming to the next question. Which one of the following decreases in a downstream direction? First option is grain size. Now, grain size decreases because of attrition and abrasion. Like say, grains carried by any medium got eroded either by abrasion or attrition on moving to the downcurrent direction. And because of abrasion and attrition, grain size decreases in downstream direction. So this grain size decreases in downstream direction. This is clearly mentioned here that say first grains were coarse grain, and then because of attrition and abrasion these become fine grain. Okay, now coming to velocity. Velocity of a stream usually increases downstream, though the slope of a stream typically decreases, but gravity, elimination of wet roughness, and increase in amount of water from entry of tributary tends to increase the velocity. Okay, now viscosity. Viscosity, what is viscosity involved? Viscosity means viscosity of any, you can say any current or any say water involves dissolution of finer particles. Okay, and going to downstream, fluid become more viscous because of finer particles which are produced by disintegration or breakdown of this coarser material. So viscosity also increases in downstream direction. Discharge is property of width, depth and velocity. Okay, and this is found by multiplication of width, depth and velocity. So clearly velocity increases, width also increases and depth also increases in downstream direction. So discharge of stream will increases in downstream direction. So all these parameters increases in deep downstream direction, but grain size decreases in deep downstream direction. So the correct answer is grain size. Aeolian cross-bedding is generally steeper than the current cross-bedding because. So first is angle of repose for sand is greater in air than in water. So let's say check what is angle of repose. Angle of repose is the critical angle of stability. That is, it is the maximum angle of a surface with horizontal, after which increasing few degrees particles or grains will start flowing. Like say this is a surface and this is its horizontal surface. Now this theta1 is angle of repose. By increasing few degrees of this, grains or particles will collapse, which reduces the gradient to one at which the slope is stable again. So now if we say this slope, this angle is angle of repose, then at this slope, or you can say at this surface, grains or particles will be stable. But if this surface becomes like this, or you can say become more steeper, then the grains that will be deposited will flow down, or you can say will collapse. Now, this angle of repose is greater in case of dry sand. Okay, and where we will get dry sand, you will get dry sand in aeolian condition. While in case of water saturated sand, the angle of repose, this angle of repose is less because presence of water, because of presence of water, the grains that are deposited because of presence of water, these do not stable at higher angles. Okay, so because of this, because of angle of repose, these aeolian cross bedding are generally steeper than current cross bedding. Current cross bedding are not steeper because angle of repose is less in water saturated sand, while angle of repose is greater in dry saturated sand, dry sand. Okay, so the first option is correct. The angle of repose for sand is smaller in air than in water. This is just reverse, so this is not the correct answer. Wind velocities are higher than steam velocities, or wind velocities are lower than steam velocities. Now, these are not the conditions which are responsible for the steepness of aeolian cross bedding, because wind velocities may be higher or lower as compared to steam velocities. So these both are not the condition for steepness of aeolian cross bedding. The only condition that satisfy for aeolian cross bedding is generally steeper than current cross bedding is angle of repose for sand is greater in air than in water. You can clearly understand by this graph, or you can say by this diagram. Next question is, the mountain ranges do not sink back to their original levels because. Now this question is asking that why mountain ranges are floating, why these are not sinking back to their original levels. Now this question can be explained by using a well-known phenomena, that is isostasis. Isostasis explains how the different topographic heights can exist at the earth's surface like mountains. Okay, now isostasis requires the surface layers of the earth to be rigid and to float on or in a denser substratum. So from this condition, it is clear that mountain ranges or surface layer, these mountain ranges or surface layer are supported by deep roots and float on rocks of greater density. Let's say it is a Sial and this will be Sima. Cl represents for silica and aluminum, and it have a lower density as compared to Sima, which is symbols for silica and magnesium. So it is clear from isostasis that mountain ranges do not sink back to their original levels, or mountain ranges are floating because they are supported by deep roots and float on rocks of greater density. Okay, now coming to next question. The dunes having tails oblique to the wind direction are. So these are dunes given in this option. We have to tell that in which dune have tails that is oblique to the wind direction. So first one is Barkan. In Barkan dunes, you will see that these are small crescent shaped dunes having two horns, and these horns are pointed in downwind direction, and these are not oblique to wind direction, as these are, you can say, these, if this is wind direction and these are pointing in downwind direction. While parabolic dunes are just opposite to Barkan dunes, because in parabolic dunes these horns or wings are pointing in upwind direction, while in case of Barkans, horns or wings are pointing in downwind direction. Now let's see how longitudinal dunes form. Longitudinal dunes are formed by converging winds. Converging winds in an area in which there is limited sand supply, and if it is converging winds, see this is converging winds, and these are formed ridges, parallel or subparallel ridges. Okay, and these subparallel or subparallel ridges are known as longitudinal dunes, and clearly from here, because of these converging winds, these are oblique, these are the tails of these longitudinal dunes is oblique to these wind direction. So the correct answer of this question is longitudinal dunes. Transverse dunes is not the correct answer, because in transverse dunes these are developed perpendicular to the prevailing wind direction. Now next question is, out of following, which is the characteristic feature of karst geomorphic process? So to answer this question, we should know that these features which are given in option 1, 2, 3 and 4, these features are characteristic of which geomorphic process. Okay, so first one is buried valley. Buried valley are ancient river or stream valley that has been filled with glacier or unconsolidated sediments. So clearly these features are characteristic of glacial process. Okay, hanging valley are also characteristic feature of glacial process. V-shaped valley are characteristic of aeolian process which are formed in its youth stage. I'm extremely sorry guys, V-shaped valleys are not characteristic feature of aeolian, though the V-shaped valleys are characteristic feature of fluvial landforms, and these are formed in youth stage of river, or you can say stream valley. Blind valley are characteristic feature of karst topography, and these refers to the valley of that surface stream which disappears in limestone formation through a shallow hole or sinkhole, and these because of these presence in limestone formation, these are characteristic feature of karst geomorphology. So blind valley is characteristic feature of karst geomorphic process, and V-shaped valley are characteristic feature of fluvial landform. Hanging valley and buried valley are of glacial landform. Next question says the largest delta in the world is. Okay, so the largest delta in the world is the Ganges Brahmaputra Delta, covering an area of approximately 1,10,000 square kilometer. Now, the answer is Ganges Brahmaputra Delta. Now you have to tell in the comment section the descending order of the size of these deltas. Now, coming to the next question. On a vertical section, all joint traces are observed to be horizontal. This essentially implies that. Now, first option says all the joints have zero dip. Now, if you look at this, now if you look at this block, all the joints like say J1 and J2, if these are joints, these have zero dip, that these are horizontal, and the traces, that is their impressions on a vertical section. If consider, if let us say this is the vertical section of road cutting or railway cutting, okay. So if this is a vertical section, then the traces of these joints J1 and J2 which have zero dip will be horizontal. That is horizontal traces of joints, and this is vertical section. And it is clear from this that this vertical section is perpendicular to the strike of these beddings. At these beddings strike 0 degree. Okay, so this section is perpendicular to strike of this bedding. Now, as the first question, first that all the beds have zero dip, so this might be possible in this case that all beds have zero dip. Now let us say another perspective, like say if this J1, J2 and J3, these blocks are dipping at some angle, okay, that is these have some dips, that is that may be vary from 10, 30, 20, 40, 60, anything, okay. Then if these have dip direction like this, okay, now we have to. Now, if we consider the section in which joint traces are horizontal as mentioned in the question, okay, so this will be that question, that vertical section in which joint traces are appear to be horizontal, and it is clear from this that say if this is a vertical section that we are observing in which horizontal traces, and if this is dip direction of joint, so it is clear from this observation that this dip direction of joint, this is dip direction, point to be noted, this is not the dip, okay, this is dip direction. This dip direction of joint is essentially perpendicular to the vertical section. If this is vertical section, we are considering this as this, and this is the dip direction of joint, so it is essentially perpendicular to the vertical section. Okay, so from here it is clear, or you can say this is the most appropriate condition, that if joint traces are appear to be horizontal, it essentially means that dip direction of joint is perpendicular to the vertical section. Okay, and this point contains the first option also. There might be doubt that why we are not considering the front section, that is this section, as vertical section, why we are considering only this as a vertical section. This is because of condition mentioned in the question itself, that we have to consider vertical section in which joint traces are appear to be horizontal. Okay, so yeah, the correct answer of this question will be the section is perpendicular to dip direction of joints as mentioned earlier. Okay, this is insufficient condition. This might be possible, but this is the one case. Okay, and in this option all the cases are, you can say, involved. Okay, and the joints are primary joints. Primary joints are those which are formed during deposition, and these may be essentially horizontal. So this is also not the condition. That essentially implies that on a vertical section all joint traces are observed to be horizontal. The observation is wrong because joints cannot be horizontal. This is also incorrect statement. So the correct answer of this question is the section is perpendicular to the direction of joints. Now let us consider the question. Boudinase develops as a type of boudinase, which are also known as sausage structure because of this sausage-like shape. These are extensional structure formed by layer parallel extinction. Say layer parallel extinction of competent layer. Okay, this is competent layer, and in which these are for, you can say, subjected to extensional pressure, and because of this extension these are, you can say, breakdown in blocks. Okay, and these blocks are known as boudins, and these are joined by a line called boudin line, and it is a lineation. So basically boudin is develops as a type of linear structure on a competent layer. Now second option is lineation on fault surface. Lineation of fault surface is described by a term Schlichten sites, which we will be discussing in later questions. Okay, foliation on folded rocks, this is cleavage or schistosity. Okay, the next option is, fourth option is stigmatic folding on incompetent layer. Basically what is stigmatic fold? Stigmatic fold is an irregular lobate intestine like folds that forms where single competent layers are enclosed in a matrix of low competent layers. So this is also not the boudinase. Okay, so the correct answer of boudinase is these are linear structure on competent layers. Okay, the fold type given in the figure is, there is a, you can see, you can see a figure of a fold. With this fold we can observe that hinge line, okay, hinge line is the maximum curvature, line joining points of maximum curvature, and in this fold hinge line is plane, or you can say hinge line is straight, not plane, hinge line is straight, and if hinge line is straight then the fold is termed as cylindrical. Now cylindrical, these non-cylindrical, these second and four options are eliminated because the fold is cylindrical because of straight hinge line. Now say if this hinge line would be straight, sorry, would be curved, then the fold will be termed as non-cylindrical. Now the next observation is, look at its axial surface. This axial surface is also folded in this fold, and if axial surface is also folded then the fold is termed as non-planar. So clearly from first and second observation we can say that this fold is non-plane cylindrical. Now if this axial surface would be planar, then, or you can say would not be curved, then this fold will be considered as plane cylindrical, because in case of plane cylindrical there is a straight hinge line and planar axial surface. In case of plane non-cylindrical you will get curved hinge line, curved non-cylindrical curved hinge, and in case of plane you will get planar axial surface. In case of non-plane you will get curved axial surface. Okay, so as far as the question is concerned, this fold is concerned, the correct answer is non-plane cylindrical. Coming to next question. A typical tectonic plate is made up of. So first of all, what is tectonic plate? Tectonic plate are the segments of lithosphere, and lithosphere is itself part of crust and upper part of mantle. Okay, so and these tectonic plates include continental and oceanic crust plus part of upper mantle as described by lithosphere. So clearly this is not the correct answer because it consists only of continental part of crust, because tectonic plate are made up of continental part plus oceanic part and also upper part of mantle. Continental and or oceanic part of crust, this is also incomplete because this doesn't involve upper mantle. So this is also incorrect. Crust and upper part of mantle, this is correct. Lithosphere and asthenosphere, this is incorrect because tectonic plate are segments of lithosphere, not of asthenosphere, though these are float upon the asthenosphere. Okay, but these are not part of asthenosphere. So clearly this is also incorrect. The correct answer of this question is crust and upper part of mantle. Next question is saying that which of the following statement is not true about remote sensing. Okay, so we have to tell that which of the following is not true. So we should know that which of the following is true. If we know that among these four which are true, then we can easily find out which is not true. So first one is NRSC. NRSC means National Remote Sensing Center, which is located in Hyderabad, Telangana, and it is one of the centers of ISRO that manages data from the aerial and satellite sources. Okay. So clearly NRSC is the chief agency dealing with the remote sensing in India. This is the true statement about remote sensing. Now, second is active remote sensing entirely depends upon the reflection of sun rays. This is false because active remote sensing sensors have its own source of light. This doesn't depend upon the reflection of sun rays. While passive remote sensing center entirely depends upon the reflection of sun rays. So this statement is only true in case of passive remote sensing, but not in case of active remote sensing. So this is clear that this is not true a statement about remote sensing. Images are taken from satellite as well as aircrafts. This is true about remote sensing. And electromagnetic radiation is widely used. This is also true because there are several regions of the electromagnetic spectrum. For example, ultraviolet rays. These have shorter wavelengths and these are useful for various aspects of remote sensing. Okay, so electromagnetic radiation is also widely used in case of remote sensing. This is also true. This is also true. These three statements are true. The only statement which is not true about remote sensing is this. So the correct answer of this question is second. Now coming to next question. Okay, so transform fault is a. So basically this is asking about the type. That transform fault is a type of strike slip fault or normal fault or reverse fault or thrust fault. Okay, so in normal fault, hanging wall moves downward with respect to footwall. In case of reverse fault, hanging wall moves upward with respect to footwall. While in case of thrust falls are low angle reverse fault in which fault plane is less than 45 degree. In strike slip fault, two beds or two blocks move transform to each other. Okay, there is lateral transformation, slide past to each other. So transform fault is a type of strike slip fault and these are associated with oceanic regions. These are generally associated with oceanic regions. And other than transform fault, transcurrent, transverse and range fault, these are also terms associated with strike slip fault. Now, so the correct answer of this question is strike slip fault. Next question is continental dip theory was given by. So continental dip theory was given by Alfred Wegener in 1912. So the correct answer of this question is Alfred Wegener in 1912. Let's see other scientists that these scientists gave his theories. So first one is Harry Hayes. Harry Hayes proposed the seafloor spreading hypothesis. Wine and Matthews, these noticed the symmetrical pattern of magnetic strips on either side of the mid-oceanic ridges. They published this idea in 1963, which named magnetic anomalies over oceanic ridges. Now, it became then the Wine-Matthews and Morley hypothesis, recognizing the work of Canadian geologist Lawrence Morley, who had independently come up with the same idea. So, basically, Wine and Matthews and Morley, okay, these two scientists together have you can say noticed the symmetrical pattern of magnetic anomalies, okay, and magnetic anomalies over oceanic ridges, and the same concept was observed by you can say Canadian geologist Lawrence Morley. So okay, so according to these three, as per these three scientists, their hypothesis named the Wine, Matthews and Morley hypothesis, okay, and it is related to the magnetic anomalies over oceanic ridges. Now, Dutton was the first scientist who proposed the term isostasy. After this, Airy and Pratt also came, but Dutton was the first who proposed the term isostasy. So, as far as continental drift theory is concerned, the correct answer is Alfred Wegener. Next question is Schlieren sites are a type of. So in question number 12, we have discussed that lineation on a fault surface is termed as Schlieren site. Now let us see it clearly. Say this is a block A and this is block B. Along these, there is a movement, or you can say these blocks slide past each other. So this is associated with a faulting, and this is the fault plane that you are observing here. Okay. And because of the movement of these blocks, there are striations, okay, or scratches which are present in fault plane, and these scratches are lineation and these are known as Schlieren sites. So clearly Schlieren sites are type of lineations. These are not type of foliation, neither bedding and neither fault plane, though these are associated with fault plane, but these are not a type of fault plane. Okay, these are features or you can say lineations formed in fault plane. Okay, so the correct answer of this question is lineations. Coming to next question. Next question says, which shows the highest strain level value at present among all the Himalayan thrusts? So according to a research paper, the main central thrust along which homoclinal block of crystalline rocks of the greater Himalaya is thrust over the younger sedimentary belt of lesser Himalaya. That is, the main central thrust is the area, or you can say the thrust, which divide lesser Himalaya to the greater Himalaya. And strain measurements along this thrust shows that the main central thrust coincides with the highest strain value at present. Okay, so the correct answer of this question according to a research paper is main central thrust. Next question is, line connecting points of equal thickness of beds are called. So first of all, we should know that these terms are associated with which type of lines. So first of all, isohyets. Isohyet means these lines that join points of equal average rainfall. These are terms as isohyets. While isohaline, these are the lines joining points of equal salinity in the ocean. Isobaths are the line joining points of equal depth below the water surface. And isopacks are the line connecting points of equal thickness of beds. And this is the question asking about, so the correct answer of this question is isopack. Now, next question is, what is the unit cell symmetry of monoclinic crystal system? Okay, so now we have to tell that which of the following HM symbol represent the unit cell symmetry of monoclinic crystal system. So first one is 1. This symbol represent the form PART-1, which is of triclinic crystal system. So this is clearly not the unit cell symmetry of monoclinic crystal system. Second is 2/m. This represent a monoclinic prism, and which is form of monoclinic crystal system, and it is the unit cell symmetry of monoclinic crystal system. So the correct answer is 2/m. 2/m. This form is represented by rhombic dipyramid, and it belongs to orthorhombic crystal system, and also it is unit cell symmetry of orthorhombic crystal system. While 1m, that is 1 meter plane, if it is m, then it is considered as dome, which is a form of monoclinic crystal system. As far as unit cell symmetry of monoclinic crystal system is concerned, this is represented by 2/m. Now, coming to next question. Which of the following is not closed crystal form? What are closed forms? Closed forms are those that enclose space without other form being present, like cube, octahedron, and dipyramid. These are type of closed form. While those forms that do not completely enclose space, that are termed as open forms, like pinacoid, pedian, and you can say prism, okay, pyramid. These are all type of open form. So clearly the question is asking about which of the following is not a closed crystal form. So cube, octahedron, and dipyramid, these are closed. Pinacoid is only one form, that is open. So the correct answer is pinacoid. Coming to next question. The crystal system which shows highest degree of symmetry. So normal class of isometric crystal systems represent the highest number of plane of symmetry, that is 9, highest number of axis of symmetry, that is 13, and center of symmetry is also present. So clearly isometric crystal system shows highest degree of symmetry, while triclinic crystal system shows lowest degree of symmetry, in which only center of symmetry is present. Other two crystal systems present in the question are monoclinic and tetraconal. Monoclinic have one plane of symmetry, one axis of symmetry, and center of symmetry is also present. This is the second least crystal system which shows second least degree of symmetry. Okay, and tetragonal crystal system have 5 plane of symmetry, 5 axis of symmetry, and the center of symmetry is also present. So as far as highest degree of symmetry is concerned, it is represented by isometric crystal system. Now next question is, which of the following is not a biaxial negative mineral? So this is optic sign. Okay, now we have to know the optic sign of all these four minerals to answer this question. So first one is talc. Talc is a mineral of phyllosilicate, or you can say a clay group of mineral, and it belongs to phyllosilicate, and all the clay group of minerals, or you can say all the phyllosilicate minerals are biaxial negative, though these are clay minerals, or these are, you can say, mica group of minerals. So mica group of minerals and clay minerals, all these are biaxial negative. So talc and muscovite are biaxial negative. Orthoclase belongs to K feldspar, and all the K feldspar, whether it is orthoclase, microcline, or cyanidine, these all are biaxial negative. Okay, so all these three minerals are biaxial negative. Only staurolite is biaxial positive mineral. So the question is asking about which of the following is not a biaxial mineral. So the correct answer is staurolite. Now coming to next question. Now the light traveling through anisotropic minerals is. So this is a very basic question in which the light traveling through an isotropic mineral is always doubly refracted. That is, the light rays is split into two rays of different velocities. Okay, so this is a special property, or you can say property of an isotropic mineral in which light will be doubly refracted, or you can say double refraction will takes place. Now next question is the difference between maximum and minimum refractive indices is known as. This is also definition of a term, and the term is known as birefringence. Birefringence means the difference between maximum and minimum refractive indices. Okay. Now let's take the options. First one is extinction. Extinction is the property in which mineral go dark on stage rotation. If it is an isotropic mineral, it will go dark on every 90 degree on stage rotation, and if it is isotropic mineral, then under cross polar it will remain dark throughout 360 degree rotation. Pleochroism is change in color under plane polarized light on stage rotation. And birefringence, I have told you that birefringence is obtained by the difference of maximum refractive indices and minimum refractive indices. Absorption is the process of absorbing light or anything which is under observation. Okay, so the correct answer of this question is birefringence, which is the difference between maximum and minimum refractive indices. Next question is which of the following mineral is odd one out due to polymorphism? Now first let us check these minerals. First one is calcite. Calcite have chemical composition CaCO3, magnesite have MgCO3, siderite have FeCO3, and cerussite have PbCO3. Basically these all are carbonates. Now these all have different cations Ca, Mg, Fe and Pb. Now these minerals, you can say calcite, magnesite and siderite can be grouped, or you can say belongs to a group known as calcite group, while cerussite belongs to aragonite group. So this is the first criteria, because due to which we can choose odd one out, or you can say we can choose our correct answer cerussite, because cerussite is belongs to aragonite group of mineral, while calcite, magnesite and siderite, these three belongs to calcite group of mineral. Now this polymorphism which is given in question is quite confusing, because you know for polymorphism the chemical composition should be same, and the you can say the crystal system should be different. Okay, but in all these four you will see that chemical composition is different, that is CaCO3, MgCO3, FeCO3, PbCO3. For example, like say calcite and aragonite, you have heard about that, calcite and aragonite, these two are polymorphic minerals, and both of these have chemical composition CaCO3, while calcite crystallizes in trigonal crystal system and aragonite crystallizes in orthorhombic crystal system. So this is the best example of polymorphism. But in these four, polymorphism is not occurring. You can say polymorphism is not the property out due to which we can choose odd one out. Okay, but we have other options. As I have told you that these three minerals belongs to calcite group, and this cerussite belongs to aragonite group. Now again, these calcite, magnesite and siderite, as their you can say cation is different, but these crystallizes in a similar point group, that is bar 3 2 over m. And if this happens, that cation is different and but crystallizes in same point group, this property is known as isostructuralism. So we can differentiate, or you can say we can odd one out mineral on the basis of isostructuralism, but not with the help of polymorphism. So this is incorrect in this question. Okay, so we can easily differentiate on the basis of isostructuralism and on the basis of groupism. So the correct answer of this question is cerussite, but not on the basis of polymorphism, because of isostructuralism, okay, and because of the group that these carbonate belongs to. Now coming to the next question, which habit is commonly shown by mineral kyanite? To answer this question, we should know that the examples of these habits, that dendritic habit, massive habit, fibrous habit and braided habit, are shown by which type of mineral or which minerals? So dendritic habit is shown by dendrites of manganese oxide, and clearly kyanite is not a manganese oxide. Massive habit is shown by quartz, and massive habit means solid mass with no distinguishes features like quartz. Okay, so it may be represented by quartz. Other minerals may be also present. Fibrous habit, is represented by satin spar, chrysotile, and asbestos. It resembles fibers basically. Bladed habit is shown by kyanite and wollastonite. And the question is asking about mineral kyanite, so the correct answer of this question is bladed. Next question says, the chemical formula for mineral beryl is. Okay, so first of all, beryl is a cyclosilicate. Okay, and because it's cyclosilicate, the Si:2O ratio is 6:18. So first of all, we have to check that in which chemical composition or chemical formula the Si:2 ratio is 6:18, and it is present only in option first and option second. So these two are eliminated out of the frame. Now we have to tell that which of the following 1 and 2, which of these is a chemical formula for mineral beryl. Now we know that beryl is aluminum rich, so from this we can easily answer that beryl is chemical formula for beryl is Be3Al2SiO3 whole 6. Okay, in this is aluminum rich, and also Si:2 ratio is 6:18. So the correct answer is first. Now coming to next question. Which of the following is not an inosilicate? To answer this question, we should know that these minerals, leucite, glaucophane, augite, and jadeite, belongs to which crystal structure, or you can which silicate structure. Okay, so leucite is a felspatite group of mineral, belongs to felspatite group of minerals, and it have tectosilicate structure with Si:2O ratio 1:2. Glaucophane belongs to amphibole group of minerals, and it is double chain silicate, and it belongs to inosilicate silicate structure. Augite and jadeite, these both are other clinopyroxenes, and these have single chain silicate structure, and this is also a type of inosilicate structure. So clearly glaucophane, augite, and jadeite have inosilicate structure, while leucite have tectosilicate structure. And the question is asking about which of the following is not an inosilicate. So the correct answer is leucite, because leucite is a tectosilicate. Okay. Thank you so much guys for watching this video. If you love the content, please click the like button. Don't forget to subscribe the channel and share among your friends. Thank you.